Then we can move to another aspect. Now we have had some a presentation on liveness detection, attack detection seen from the university point of view. And now we go to a small and medium company and see how their look at that topic is. And this presentation will be given by Ann-Kathrin Freiberg. She works with BioID and will give us an interesting presentation. I will hand over the presenter to you,
Yes,
and the floor is yours.
Okay, so I hope now you see my full screen presentation. Yes, okay, very good. So thank you for the introduction and also the presentations we heard before. As Dr. Wolf said, I'm coming from, or we are coming from a different perspective because we are a solution provider in the field of identity verification. And so I will be speaking about the use case and also the challenges concerning liveness detection and deepfakes if it comes to a remote identity verification. So to begin with, I think we already know, everyone sees it, and we've also heard it today, that digital identity verification is on the rise. On the one hand, this has been a trend since globalization and due to globalization, but of course, COVID-19 has actually increased the remote verification necessity by a large scale. I'm just thinking about one of our customers who provides identity verification to the British government, and they used to have a solution for more than 1.5 years, but then last year during the first lockdown, they had to scale up their service enormously because all the branches for the British government services were closed. So everything had to move online, and I think we see that all over the world, and especially in Europe, I think remote identity verifications have risen enormously. And now we see a diversified market, as not only we have the video ident services with video agents verifying identities remotely, but also automated systems. And this is also where BioID comes from. This is the reason I will be focusing on automated systems today, but all the things I will be saying are also applicable to analyzing videos and video agent services, of course. For an automated identity verification, of course, you need to perform a few steps. One of them is to make sure that the ID is authentic. We've heard that in the first presentation as well. It could be manipulated, the picture could be manipulated, or the ID could be stolen. So sometimes Interpol databases have to be checked and things like that. So a user trying to verify their identity remotely, they would be asked to take a picture of their ID so that it can be analyzed by algorithms. The second step is that it has to be made sure that this ID actually belongs to the person who submits it. And for that, biometric face matching is performed. So we need a very accurate mechanism to make sure the ID picture is the same as the person looking into the camera. Which brings us to the third step for remote identity verification, that is liveness detection. It's also called presentation attack detection, and it means that we need to be sure that the images are actually derived from a live person and not from some type of spoof. And then if all those three checks were successful, we can say that a verification has taken place and we have trusted credentials. But of course, the question comes up, what about security? Because there are different steps, as I said, that can all be manipulated. So there need to be security mechanisms, making sure, for instance, the holographic is genuine and the ID is not stolen, that the face is really matching the one on the ID. And as I said, that no spoofing is taking place. So this brings me to the main topic of the presentation, which is liveness detection. What does liveness detection have to do in the use case scenario that we are now speaking of, which is remote identity verification? First, it has to reliably detect live versus fake input, but it also has to do that in real time and easy to use, and also hardware independently. Because if we think of the British government or the British citizens. We never know which kind of device they use and which scenario they are. We don't know if the old lady maybe doesn't have so much experience with doing things like that. So we need to be able, or the algorithm needs to be able to use any device, any camera, any lighting, and still be very reliable with its decision for whether or not the images were coming from a live person. So which spoofing attacks need to be addressed? Of course, we heard some today already and saw some pictures. 2D photos and things like image swapping with 2D pictures need to be detected. Also 2D cutouts, like I have one here. For instance, I think you can see that the eyes are open. So spoofing with things like these masks need to be rejected, of course. Then on the other hand, we also have 3D attacks. So different types of 3D masks, wax heads and sculptures and things like that. But also a very big challenge is our 3D paper masks. And I thought I'd bring you this one. Of course, we have a lab here and we manufacture spoofing attempts to make sure our system is able to cope with them. And yeah, so this is one of the more sophisticated 3D paper masks. And you can see it kind of looks like Trump, I would say, and also has some skin close texture, and it's three-dimensional. So things like that have to be addressed and also have to be detected, because although it's not easy to build these masks, it's still available for people if they try hard, a little harder. And then the third thing we need to address are video replays and video projections on different materials, because that's actually the most common type of fraud we see in the real life scenarios, that people try to use either grandma's picture or a wedding picture or some kind of video from social media on the person. Like now this video, for instance, is recorded from me, and so that means it will be available on social media and people could use it to try to spoof systems using this video of me. And of course, we have to be able to detect these. But instead of just speaking about it, I thought it would be nice to show a demo. Excuse me. So you can see that this person is actually detected a fake. And the reason for that is that it was a silicon mask. And when I took off the mask, I was detected as live in real time. This was a live demo, by the way, here in our office, maybe half a year ago. So that's when it was recorded. Yeah, and you see that I tried to bend the picture and try to overcome the system by kind of making realistic features available. But yeah, in this case, of course, it worked to detect a live person as live and the fake person. Even here with the video where it looks like me and it moves like me, it's still detected as a fake. And the question is, how do we do that? One of the steps, so we combine two different elements, and one of the steps is 3D structure analysis, meaning that we perform optical flow analysis on 2D pictures. So we need to work with standard cameras, as I said, for this real life use case scenario of remote identity verification. We don't have any depth information or 3D cameras, so we need to be able to be sure that it's a 3D geometry we see with just using 2D RGB standard cameras or pictures. And we do that by asking the person to slightly move, and then from the slight movement we can calculate this 3D geometry. So this is a very good way to prevent 2D spoofing attacks. But then we also use texture analysis and AI. And we, on the one hand, have handcrafted features for the texture analysis, but on the other hand, we use deep convolutional neural networks, which are trained with our data to make sure that the live people are, as I said, detected as live and the fakes are rejected. Of course, this is a very complicated problem because for a two-class problem like live or fake, you kind of need all types of fakes in the fake class for training. And you are never sure, you can never be sure that your system generalizes well enough to also cope with unseen attacks. So this is an ongoing research and development project. but it's already in use and very reliable, but it has to be modified all the time. So this brings us to the topic of new unseen attacks or new kinds of fraud attempts, which is deepfakes. So deepfakes, as we already heard, are becoming more challenging because they are difficult to distinguish from real videos because they're getting so good in quality. So the human eye really has problems to distinguish them, especially if they are not trained. And if, of course, the algorithms also can have challenges with deepfakes. So what is the status quo if it comes to deepfake detection? And here, the thing is that deepfakes typically, at least for this use case that I'm speaking of, which is remote identity verification, here deepfakes are presented on a display. So for instance, a video or a deepfake, a recorded deepfake is presented on a cell phone to a camera which tries to verify the identity of a person by sending the pictures to us, for instance, to the solution provider. So if deepfakes are presented at the sensor level, then the good thing is that our standard liveness detection, the texture analysis and the AI are able to detect this. Because, as I said, they are presented on a display, they are projected to some kind of material, and our liveness detection would detect all of these materials and displays. So the good news is that for this use case scenario, a secure app preventing video injection solves the problem of deepfakes. Because if deepfakes can't be injected into the application but are only presented, then our liveness detection already is able to cope with the situation. But still, we need to speak about video injections, of course. So what about deepfake attacks at the application level? So here, if we are speaking about a pre-recorded video feed, a pre-recorded deepfake, then challenge response mechanisms can be used. So the user would be asked to move in a certain randomized direction, like up and then to the side, for instance. And it's very unlikely that an attacker really has a video that or a deepfake video where the person moves in this prompted way. So this can be a way to detect deepfakes, even if they are, if the attack is at the application level. But what about live manipulated video feeds? So especially for all the use case, for all the scenarios where we're not in the use case of identity verification, but maybe a video of a politician needs to be analyzed, for instance. We also want to be able to detect whether it was a deep fake or not. And live manipulated video feeds that are injected into an application like identity verification, of course, are a challenge, and future research is relevant. Which brings me to the fake ID project that we have already heard about today. So our future research aim is to develop methods to detect deepfakes in the video and photo material directly. This is in order to make identity verification more trusted and be sure about the credentials that are derived from such automated processes, and support all the different cases where we want to analyze video material and be sure that it's genuine. Yeah. And to sum it up, I would just like to say a few words about BioID. So we are a company focused on research and development, which comes from our history. We've been founded in 1998 as a spin-off from the Fraunhofer IIS here in Erlangen. And we have our headquarters here in Nuremberg and are a German company with 100% proprietary software. And we're proud to say that we have 23 years of experience in biometrics. So we've been on the topics from the beginning. Yeah, and are happy to be able to bring the technology into the use cases now that we've been speaking about. So thank you for your attention, and I actually hope there are some questions. And if not now, then please don't hesitate to contact me later on after the conference. And yeah, thank you for having me.